Okay. It's my little script here. Okay. So for people who were watching before, we were just doing a quick question and answer thing while we were sorting out technical problems. So now I'm going to start for real. Hi everyone, I'm Aeva Palecek. I work for Lulzbot, the 3D printing company that manufactures the Lulzbot TAS and other printers. And I'm here to talk about the state of 3D printing software today and what is being developed to improve the experience for non-engineers and specifically to make 3D printing better for artists. While I'm going to demonstrate this printer, I've also brought along a number of prints which I've already passed around into the audience for you to examine. I will also try to set up a webcam at one point where I do a demonstration so you can see it on the screen up there. And so yeah, projecting the printer's activities. And yes, so first I'm going to start with demonstrating a typical 3D printing workflow with conventional, oh hey, cool. Yeah, conventional 3D printing software. And then after that demonstration, I'm going to show you how upcoming 3D printing tools will be simplifying that process. And then following that, I'm going to give an overview of how things may be improved even further than that. Okay, so first step of things. Oops, I'm going to restart that. All right, Blender. We're gonna open print demo. Okay, put that there. All right, so derp. Okay, so let's see here. Above here, you can see Blender. I've put together this mind-blowing looking file right here for my demonstration, and it's with this generic cube that I have up on screen, which I intend to advance the state of 3D printing software. I'm going to use the cube to do. Why is my thing not working? There we go. So cube. And Suzanne head. I'm going to do a quick Boolean mesh mod with this is just the normal Suzanne head. I have not modified it except just to position it for the purpose of the presentation. So I'll just do add modifier, intersection of normal Suzanne. And all right, looks good. Oh wait, look at those eyes, those dead eyes. Yeah, that's not going to work. The normal Suzanne head is not 3D printable normally because the eyes themselves are not attached to the rest of the mesh. This restriction is, this is what's known as a non-manifold mesh. Blender has a tool that you might be familiar with, which is the that one. So yeah, and it highlights the vertices that are problematic for it. So because I want to print Suzanne, because who doesn't want to print Suzanne, I've made a manifold version where the eyes are actually connected to the rest of the mesh. So I'm going to go back over here and then change that to Suzanne clean. And hey, look at that. All right, and you may recognize this already in the people in the audience. That's the same thing I printed before that I passed around, as well as other objects. Okay, so next part. Right. So first thing you do when you're printing a model is once you get it to be all printable and you've used Blender's superb 3D printing toolset to make sure your overhangs are okay and so on, is you export to STL and you save your file. And we got the print demo file right there. So export that. All right, and then you leave Blender to go to a slicing program. And this program is called Slicer, then it's spelled with an E, as you can see right there. The Slicer has many settings that are probably things that you generally don't really need to know about. Lulzbot, for your convenience, provides configuration files. I just downloaded one onto my computer for now. And this is a draft one, so it's a lower print quality, faster speed, that set these settings for you so you don't have to know what they are. We're going to add our file, which is the print demo. And hey, there she is. Okay, and we can add things. We can add more like files to the print bed and so on, but we're just going to print one copy. We're going to export the Gcode file. And the Gcode file is a set of instructions that the printer will follow. The printer itself is very dumb. It doesn't know what a 3D object is. It just knows how to do paths. Gcode file is move the printer to this coordinate. Now draw a line from this coordinate to this coordinate and heat up and cool down and those sorts of things. The slicing software will analyze the model and produce a Gcode file. So save that. Now this little bar at the bottom says generating parameters, detecting solids, filling layers, exporting. Weirdly enough, like just the generic export one is the longest one. All right, so now we have our Gcode file. Printerface I've opened up beforehand. This is called the host program. Printerface talks to the printer. It takes Gcode files. It sends them to the printer. We're going to load our Gcode file. Which is that one. And, all right. And Printerface has this nice little wheel thing that you can use to manually control the printer. I'm going to use it to home the printer. I've opened it up beforehand to set the temperatures so that they might heat up while I was babbling. And I also like to call attention up to the top here, where it has a path, dev tty acm 0, and this big number. That's a serial port and a baud rate. And normal 3D printing software, you do have to actually specify these things. And the serial port, pure system dependent, is kind of annoying. So hit print, and it starts. And I open up my system try thing. Okay. So, oh, and I forgot to do a webcam thing, so I'm going to connect that real quick. Yay! Okay, you can not really see at all. Let's see here if I can hold that better. All right, yeah, so you can see it's drawing the outline of the first layer. Is that reasonably clear? Okay, cool. All right, gonna close that then. And I'm just gonna cancel the print job now. Because I want to show you how else we can do things. Oops, that's not what I wanted to do. Okay, so okay, canceling. All right. Anybody want some industrial refuse? Here, have some industrial refuse. Okay. Okay, we're gonna close. Okay, set the temperature back. I want to keep it there. Disconnect it. Okay. Now I'm gonna open up a terminal program, and you're gonna ignore it. But I want to make okay. This is a print server daemon that I've written that you should. It's a wonderfully complicated program that I hope in my better world that you'll never have to actually know it's there. So now let's go back to we're back into Blender now. The 3D the head of the monkey with the cube modifier thing, just to go back. If we go to user preferences. And this will not work on any of your computers because I haven't posted this plugin anywhere yet. All right, import-export 3D printer integration. And it's my 3D printing tools for a better world. Okay, so we're going to export to printer instead of to STL. All right, so got a collate button here. All right. Hit print. All right, now it's slicing in the background. The printer temperature, when it canceled it, the printer temperature dropped, so it's going to have to wait until it goes back up to temperature again. But you can see this now in the little bar thing that tells you what it is. So we'll wait a few minutes.
When do you think you will release it?
When will I release it? I have all the software for the printing backend online right now on my GitHub site, and then I think the plugin is actually up there too now. So if you really wanted to try this, you could try it out. The caveat that I have here is that the printing daemon that this talks to is a Linux program, and it uses UDEV for auto detection of hardware, and it uses dbus to do inter-process communication, so that simple front ends, such as this printing dialog that we're seeing right now, I threw that together in a few hours in preparation for this talk. But there's a nice dbus API available for printing programs to be written against, so they don't have to have any printer logic whatsoever built into them. But however, that is currently Linux, and I need people to assist me with porting it to other platforms that will likely be in use.
What is your GitHub?
My GitHub username is Aeva. It's spelled A-E-V-A. The project name is there's actually several projects. Voxelpress project is the sort of like this umbrella term for it. SwitchPrint is the daemon, and VPP is the little thing that connects to it. And then I don't remember our name of the Blender plugin, but I think it's fairly aptly named. All right, it's starting. Let's open up the thing again.
While this is running like this, is it possible to still use the control program just in case you wanted to?
Yes, there is a
Conflict or
the control program that I showed you before won't work with this, but I have written a replacement for it called PrintControl. It's not a GNOME app, so I have to open it with command. And which does all of the same stuff, except that it works completely automatically and it has no printer-specific logic built into the program. So PrintControl has, as you can see, you can monitor the temperatures a little bit more scientifically. There's a little click wheel thing that you can use to follow it along. I mean, not to follow it along, to move the print head automatically. Okay, open up.
You've said what material you're using.
Come again?
Your settings for ABS or PLA should be slightly different.
Yeah, so this is, because this is a demonstration, I had hard-coded that in the background, but the an upcoming feature for SwitchPrint is to be able to differentiate between printers that you have connected to it and to store configurations for them, even to go as far as to auto-detect what kind of printer you have. There would be an option in that first screen where I had the joke with the collate button to have actual printing settings, like do I want to have the temperature settings that are appropriate for this machine for ABS plastic, or do I want to have the temperature settings that are appropriate for this machine for PLA plastic, or wood fiber suspended in plastic, or chocolate, or polycarbonate, or the many exotic materials that are available for 3D printing. All right, so I'm gonna let that run. I'm gonna in the background while I go into this next bit. So it doesn't have a time estimation, but the time bar will actually move as the thing makes progress throughout the prints. Uh-oh. there is a bug in the printing daemon where sometimes Gcode commands are getting corrupted when they get sent to the printer. It's not really ready for people to use for production stuff, but it's getting very, very close. And in fact, now because it homed on its own by accident, I'm going to cancel the print because it's going to produce garbage. So. Which the way I canceled it is also kind of counterintuitive, but I don't have a cancel function built into it either. So, even in my sort of full, the whole, this is how we're going to do things better, there's some work that needs to be done before this is ready for people to actually use it. But when it's what I actually expect people to have to interact with is a couple of buttons, really just a few buttons, a selection of what kind of filament you want, which printer you're using, and then you hit print, and then it works. That's the requirements of the user to be an expert in 3D printing is no longer a main requirement. Users are going to be free to focus on using 3D printers as an artistic tool rather than as an engineering pursuit. So I have some slides I made for the next part, I think. Let me consult my notes. I kind of went off the tracks. I had this perfect presentation planned out about my airplane trip here. It was a very, very long time to think on a ride from Chicago. Okay, so all right. Right, so I actually also had a few points I wanted to enumerate about the current tool sets, which is the first demonstration, not the second demonstration, which is while these tools work well, they're actually a lot simpler. If you can imagine the software that had preceded it a few years ago, there is a lot to be desired from them, and then in no particular order. One, you have to leave Blender to start up your print job. Two, just because the model looks like it should be printable, in the case of the Suzanne head, does not mean that it actually might, it might actually mean that it won't be printable. Yeah, and the interfaces themselves are not that particularly intuitive, and even though the printers themselves are USB devices, they currently are not plug-and-play devices. That's partly to do with the bureaucracy involved with getting things like a vendor ID assigned to you from the standards body, which is somewhat difficult for smaller organizations to work with. But let's see here now. I don't need that part. Okay. I think the printer is $2,200 in US dollars. We recently started. This is actually the TAS 1. We recently just launched a crowdfunding, fundables.com, for the second run, which is an improved version of the machine that you see before you. That is the TAS 2. Yes, yeah, and where was I? I don't know what the state is of production right now, but we try to make our shipping stuff internationally friendly. We have fulfillment warehouses in the UK and in Canada and the United States and so on. So, but yeah. So while the software I had demonstrated itself is not quite feature complete, as we discovered when I tried to close it, for it to serve as a full replacement for the conventional tooling that we use. I do believe that that what is there solves all of the problems that I'd outlined with the conventional tools, with one exception. And that is that for a model which is non-manifold, the non-manifold models still have the same problems that your printer may outright refuse to use it. The slicing software will be like, nope, this sucks, don't do it. Or it might do surprising things and not inform you that it ran into a problem because your model is non-manifold. So this problem is actually shared by both conventional tools and mine, and that is because the program slicer is actually being called in the background by my tools. So I do have a solution for this problem, this mathematical restriction, but before I go into it, I'm going to give you guys a course explanation of how slicing software works. With my very, very expertly put together slides here, the most professional. So this image explains how current slicing engines typically work. The image is, imagine a stack of planes that run along the z-axis of your model and that they intersect your model, and that those planes are spaced apart in accordance to your printer's resolution. So you have one plane per layer of filament that needs to be laid down. So that is the top left image is the planes intersecting a sphere. The top right image with the little connect the dots thing going on there is the line segments that your printer, or rather your slicing program, finds within the model intersecting with the plane. You have a set of line segments. Those line segments actually get translated quite directly into printers' commands of like move here, move here, move here, move here, move here. The bottom left image is you take the line segments and then you make a copy of them and you can inset them, SEPs, and that makes additional filament walls to make your print stronger. And then the lines on the inside are added where you can cross-hatch on the inside of your printer or your printed model, and that will make the model sturdier. And then it will also help with places where the thing goes like this. The part inside of it will be supported by its own internal volume. And then the last image is a drawing of a nozzle putting together the sphere. Voxel models, on the other hand, where we use vector models for 3D printing, and the process that I described is what I call a vector-based slicing engine. I just want to outline that. A voxel-based slicing engine has some interesting differences in how they would work because it tends to be more spatial reasoning, the logic behind the writing the algorithms, whereas vector ones tend to be very math heavy and clever in a way that turns off a lot of people from wanting to develop them. The voxel-based slicing engine has a neat cleanup algorithm that's really easy to do. On the top left corner, you just have your two spheres, and let's say they're intersecting each other, so that there's this sort of Venn diagram in 3D space that would be a non-manifold thing. Because of that extra material that you probably don't even need. Like say you're trying to print a face, and then your face model has eyeballs that are just spheres, and the eyeballs look like they intersect with the face model well enough that it looks like it's a solid thing, but when you try to print it, suddenly you have these hollow spaces where the eyeball and the thing intersect with each other, and that would be error from a non-manifold print. So to solve this, we do, because our voxel models are expressed in a three-dimensional bitmap, we'll do a color fill algorithm to identify the negative space surrounding the object, but ignoring the negative space inside of the object. The original model data is dropped, and the negative space volume is then used. The negative space volume is inverted to make the cast volume, which is the one on the bottom right. The cast volume then can be turned back into a vector model through something like the marching cubes algorithm, which looks very much like the blocky remesh modifier in Blender. Only it would be at a very high resolution for one that corresponds to your 3D print resolution settings. Therefore, you would not see the blockiness thereof. Or if it was kept as a voxel model, then you can continue on with your slicing process and use that to generate your toolpaths. So the casting visual aid. Right. So notes. I had originally intended to build a full slicing engine out of this when I first started, which is actually the name of the Voxelpress project. The vector-based slicing engines have seen significant improvements in both usability as well as in speed over when I had first started working on the Voxelpress project. It may make more sense now for this just simply to be a filtration system in the beginning of the slicing process. So you have a program that takes a model that's in vector form that Blender would export to convert it to a voxel model, do the casting process, and then convert it back to a vector model, and then run it through Splicer. This would allow me to focus more on the other aspects of the project, for example, adding the cancel button or porting it to other platforms. This would to bring it to a state where people can start using it, and I think it would also be a better community member of me if I built off of the groundwork of off of the good work done by others in the community, rather than trying to just simply duplicate their work. Anyways, that's the crux of what I hope to show you today. And I hope this talk was informative, and which there most certainly is time, because the next talk time slot is not there. So I would like to open up this up to questions now, and then you're also welcome to come up to me and talk about things further throughout the conference. And final slide. So, you there?
Yeah. So am I right in thinking that the Voxel system is from an artist side, it's basically a rematch system to make a print-ready model from whatever you input?
So the question was if the Voxel system is similar, basically the rematch system. What was the question?
Yeah, essentially.
I guess what I'm asking is, just to clarify, with the Voxel system that you're working on, it's essentially just from an artist's perspective, it's merely a system to create a print-ready model very easily without having to go in and fix all of the non-manifold areas and things like that manually, or is that correct?
That's what I'm proposing doing with it. The other half of that was to actually build a full slicing system out of a voxel-based system. There are printers that actually would make more sense to have raster data available than to have vector data. However, those will probably not become a consumer available product until the patents on them expire, which is a little ways off. And is my personal belief and experience with past experiments with this, that you could build a slicing engine that's hardware acceleratable, that would have instantaneous slicing times, and that would be easier to do that with a voxel-based system, but you'd have a huge memory requirement for that. Yes, sir.
Thanks. What are the dependencies of these systems and this software that you use to connect with the printer in the Linux system that you are using? Because I saw the Debian logo there, but I usually saw that many new machines of this kind and so are so prepared for Ubuntu and so this kind of friendly user-friendly distributions, but not so in more user-advanced distributions as Debian or so.
Okay, so the main Linux requirements for running this are Python dbus and GUdev for hooking into GObject events for Python, or GObject events for UDev, and Python bindings for dbus. There are some other dependencies are the Python serial library, and eventually the daemonization library, but I think that's the gist of it, really. Either. Actually, it'd probably be easier to come up here, and then people could see us on stuff, so.
Is your voxel engine able to work only on closed? Because your example is two meshes intersecting, but both of them are closed. But many often, when you try to print something, you have a model that have very small holes that you cannot detect by eyes. Is your slicing engine able to guess that when a hole is smaller than something, then it's not a hole and it is working on a volume? I don't know if you get me.
Currently, there is not a mechanism for that. I have thought of a few ideas of how you might do that. One of which is if the gaps are small enough that it should be able to detect the distance or the size of a gap in a given layer, and if it's small, if it's particularly small, it can close it for you, or if it's particularly large, it can warn you that the mesh is not printable or will print with unexpected results.
I'm partly asking to lead questions, but I think in response to the question that he asked earlier, which was about I have two questions. The first one would be, would it basically be the summary is, and this is like asking a statement instead of a question, but I think a good summary of things is that you're trying to make a system that's, if it looks like it should be able to be printable, it just is, right?
Yes.
That's your summary, right?
Yes.
Okay. So, and the other question is, so if somebody was asking about like the design of this and compared to the MakerBot, what's the other aspect possibly community-wise why the LulzBot printer might be more interesting than something like MakerBot?
Oh, the LulzBot printer is a link. Thank you for those prompt questions. Chris is a friend of mine and has heard me talk quite extensively about these things. The LulzBot 3D printer is a free open hardware printer. Everything is open source about it. The software that runs it is free software. The bill of materials for all of the parts that you need to put it together with is available online. We're working on a collection of actually step-by-step tutorials to assist people with building one of their own if they wanted to. You could build one of these from scratch, and that would be awesome, and we would be really excited to see that in the wild if that happened. And we give you all the tools to modify it. The printer actually comes with a complete toolkit to take it apart and put it back together again. If people experiment with making their own upgrades to it. I have tried out a couple of community-contributed upgrades that are kind of awesome, and it's really kind of neat to be able to use your printer to print a part that you put into your printer, and then your prints get better. So it's cool. So, yes. I'll come on up so people can see you.
I have three fast questions.
Okay.
First of all, you told about this, you have two spheres, and I had a problem because I work with these 3D printers. The normals, we say you have one sphere with the normals outwards and the other sphere is with the normals inwards, then you have problems. But when you slice it, you should be able to see where, the contour should be outwards always. Do you understand? But when you 3D print, it has problems if you have the normals to the inside. Even if you recalculate, you have problems with that. The other question is, I saw the table and the head moving. Does it make it faster to build it? Yeah.
Okay, so first question with the normals. If your normals are wrong, that can trip up slicing software because the slicing software may try to cheat and use the normals as an indication of where the inside of a shape is. Second one is that the print bed moves independently. It moves along the y-axis, and that makes the mechanical side of things a little bit simpler. But despite the model being attached to it and being moved back and forth, that actually doesn't really have any kind of impact on the part quality. I'm guessing that was probably the other half of that question. Or you were referring to the table itself, which is kind of a wobbly table, and that is why the table was moving, because there's a vibrating machine on top of it. And your third question is?
The last question. What's better with this than a MakerBot and a reprap? It's open source also. What is better?
It is a reprap. So what's better than MakerBot? Well, the MakerBots, they haven't changed their print design much after they started shutting out community contributions. And I've noticed in the last 2 generations of MakerBots, their extruder design has remained the same and is notoriously fussy, that it is prone to print jams, and it is very difficult to take apart and to assess. MakerBot's customer service is very slow. Lulzbot, at this point in time, if need be, the CEO will get on the phone with you. So we take our support of our customers very seriously, because these are complicated machines and they are prone occasionally to malfunction. But and that it's important that you don't just have somebody buy a machine with this belief that that it is and this is true of all 3D printers, that anybody who says that they have a 3D printer that is perfect and they'll never need to be serviced is a liar, and they're trying to sell you something. I'm an engineer, so I'm not trying to sell you anything. Is that 3D printers do occasionally need to be tuned, they do occasionally break down, and it's very important that our customers have the tools to be able to fix this, and not only in the literal sense of tools, but also in the terms of having support behind them to keep their machines running.
You also have a bigger print bed.
Also, yeah, our print bed is bigger.
Yes, I have a question about your use of teapot.
So the question about the Utah teapot, which I had passed into the...
Is this printed with your Voxel program? Is this Voxelbased?
No, this is not a voxel-based model. This is actually
very smooth.
Yeah, although if I was using a voxel-based model, it would still have smooth curvature, because the resolution would be fine enough that you wouldn't notice it.
That's my question, because then you use ISO surfaces?
Yes.
Yes. And how much then is the grain, the resolution?
Oh, the resolution on it? I think that the layers themselves are 0.2 millimeters, which is somewhat coarse for what our printers can do. And the XY resolution is not constrained. We're actually there is a theoretical minimum to the smallest distance you can make the printer head move, but I don't know what that is, and I think it's negligible.
2 millimeters.
Oh, no, on the XY plane, so a thing moving back and forth. There is I think it might be either the stepper motor or something like that, but and pitch and gears and shit like that. I'm a software person.
My basic question, for instance, if you would print this with the Voxel process.
Oh, if it was printed with the Voxel process?
Some kind of little Minecraft.
No, the Minecraft screenshot was shown because that is widely recognized, but the resolution that is shown in Minecraft is not necessary for 3D printing, and it would actually be much lower. The resolution of the model actually would be set based on what your printer's actual capable stats are, so that way the resolution, whatever coarseness that would be caused by voxels, would actually be invisible, because the voxels themselves would be about half the size of your print resolution. Yep. Oh, also there's stickers appear in flyers and stuff, so if you're interested, and I have business cards if you want to contact me, and feel free to just walk right up and grab them if you want, if you're interested, or come up afterwards.
Yeah, just one question. Is the Lulzbot able to print an object with multiple materials, or do you have a plan?
It's possible to upgrade this so that you have a two extruder system. We don't sell a dual extrusion system as of the current date. But what's really cool is you can use separate materials in each extruder, and so we have for ABS you can use a high impact polystyrene as or HIPS as your support material, and it either is soluble or is otherwise easy to break off and has really good results. I have heard that for PLA as your primary printing material, you can use PVA plastic as your support material, much the same end. PVA can be dissolved by water.
And But if the object has also a complex texture with several colors, it cannot.
We don't have color printing yet.
Okay.
However, a voxel-based slicing system would be better at supporting color printing than a vector-based slicing system, just saying. Yeah, go on. Oh.
Thank you. Well, two questions. One, when do you think the new software will be, ready for mass production or use? That one.
Sorry.
Did anybody hear that? Yeah.
It's a talk right into it.
Okay. So yeah. So when do you think that the new tools you developed will be available, and ready for use for everyone?
I think the number of lingering things that need to be fixed for it to be just the Linux version to be useful. I would take not that long to finish. The two main things that I think would need to happen is that I would need assistance with getting it set up with several packaging systems for Linux, and then as far as porting it to Mac OS and Windows, I'm not familiar with those two platforms in terms of development, and so I will need help with from people who have experience with hardware abstraction layers in those systems to do all the plug-and-play stuff. So for Linux users, probably I think I'm hoping to have maybe in a month or so have a package that people could at least download and try, and then at some point shortly after that, maybe hopefully probably get into Fedora's packaging system sooner than Debian's, and I don't know much about the Ubuntu community and process for adding new packages. So. But yeah, does that answer your question?
Yeah, it does.
Okay, cool.
Okay, thanks.
Yep. So I think it's lunchtime. I don't want to keep you all past food and stuff. So unless there's any burning questions, I think I'll take two more questions and then we'll wrap it up. Okay.
Make us work for it. So what resolutions are currently available on this, and how do you measure a resolution in 3D printing?
Okay, so we usually measure the resolution in layer thickness, and the current layer thickness. It's probably easier to measure it in print head diameter, because that tells you how fine the little line you draw can be. These ones have interchangeable nozzles, so it's possible to manufacture ever smaller ones and upgrade it with it, but we ship with a 0.35 millimeter nozzle. The nozzle size tends to also have a little bit of an influence on what your layer height is. That is dependent on materials. I've been printing in 0.2 because there's a trade-off between speed and detail. With PLA, people show off by measuring their layer height in microns. So some of it. The actual resolution that's possible is actually to some extent a software-dependent feature because you have to have a good configuration, so much more so than a mechanical one. So the answer kind of depends on how much you're willing to tinker. All right, one more question.
Very fast. With your Voxel-based software, so you get small cubes, but I think most of the 3D printers, they work with Gcode, which is straight lines. So there will be needed a conversion of like that, of steps to straight lines. Or are those, okay.
Okay, so the question is, how does, when you have voxels, which are our system of bitmap, basically, and Gcode, which is a vector language that explains toolpaths, the way that you convert between the two of them, you'd have to have at some point a tracing stage where it takes a voxel layer and it determines the contour of each of the volumes that are present inside the voxel layer. I haven't done a lot of research into it, but I've seen things that do that are quite fast, and so I'm fairly confident that would be reasonably straightforward to approach. Another way that you can look at voxels as being is rather than being like a bitmap, you can think of them as coordinate triples, in which case the paths you can think of as x, y coordinates. I mean, Gcode is a system of giving coordinates to the printer, so it kind of translates pretty well, actually. Huh? I'm kind of deaf, Chris. You need to talk louder if you want me to hear it.
Never mind. I was thinking.
It's time? Yeah. Okay, well anyways, I think that wraps it up. I hope you all enjoyed yourselves. I kept most of the room here, so that's good. So, thank you. Also, Bassam, who is in the room right now, named the project that I'm talking about today. So, thank you, Bassam.
Tools